Okay, let me say a tiny bit about what these masterclasses are about and what they're not about. What we're trying to do here is give you a sense of how to use Erlang in anger. We're not trying to teach you new things about Erlang. We're not trying to teach you the constructs of the language. But what we're trying to do is take parts of Erlang and show how in practice those get used to solve real problems. So, what I'll do in the first one is show you how the functional programming, the sequential part of Erlang, how those aspects of the language are used to solve particular problems of language processing. After that, Joe will dive in to look at the concurrent part of Erlang based on message passing, and then Francesco will look finally at the OTP library and design patterns. And in each of those, they'll talk about the general ideas, but then dive in and do some serious problem solving. So, let's get started with the first masterclass. Let me say what we assume you know, what we're going to illustrate. We assume you know about the data types in Erlang, the fact you've got atoms to represent themselves, you've got numbers and booleans to represent simple data, and you can put these together using tuples and lists, so you can build complicated structures from those simple components. We assume you know how to define an Erlang function, and that you put those function definitions in modules. We assume you've used the Erlang read, evaluate, print loop in the Erlang shell so that you're used to writing a definition, putting it into Erlang, compiling it, and then trying it out with some test data. Also, we assume you're familiar with pattern matching and recursion. Those are the two of the things I'm going to illustrate in this particular masterclass. But remember that pattern matching is used to distinguish between different cases and also used to extract components of complicated data structures. So it's a very powerful mechanism. And finally, remember that recursion is there as the main way that we build programs that repeat, programs that loop, programs that do serious processing over data structures. And finally, we'll use one or two things from the lists library. So I'm going to assume that you know what's going on in that library. Okay, so let's get started on our list of what we hope that you're going to learn from this. One of the things I'll illustrate is how you use data types to represent complex data. If you're familiar with OO programming, you'll see this as using objects and subclasses and so on. We represent data much more directly in a functional language, and you'll see how we do that and how that matches with pattern matching. We'll talk about different ways that you can process structured data. We show you how to define types in Erlang using the type and spec directives, which have been in Erlang relatively recently, but are getting used more and more. We'll show you how to build a suite of functions to process a particular sort of data, and an API that works with that. And finally, you'll get experience of extending an existing program, because we'll finish the masterclass with a whole set of suggestions of things that you can do yourselves to take these ideas on, to consolidate what you've learned from following this masterclass, and also try things for yourself. So, that's what we hope you'll learn. What are we going to look at? It's almost a classic in computer science that computing is to do with programming languages. And so, if you've done a computer science degree over the last 30 or 40 years, you may well have done a course on compiler construction. But people say, you don't need to learn that any longer. Compilers, nobody builds compilers these days, or very few people build them. Why do we need to learn about processing languages? The answer is that languages are everywhere in computer science, everywhere in programming. You have languages like XML to represent data, SOAP and REST to represent different sorts of styles of calling functions on the web. You have HTML, CSS, which are used to represent structures of web pages. If you write a book or you write a large article, you'll probably use a text processing system like LaTeX or DocBook. If you build a system, you'll use something like Make or Rebar. And there, in order to use that system, you have to describe the construction of the system using a little language. Big data has become very fashionable. If you're going to do data analytics, you're going to have to read log files, you're going to have to read data in all sorts of formats, and then process them using statistical languages. If you write tests, you use a language. So all sorts of places you use languages, and often you yourself will have to write language processors, particularly if what you do is write a domain-specific language to solve a problem in a particular area. And that's something that functional programmers do a lot, not just in Erlang, but in Lisp. They've been doing it for a long time, also in more modern languages like Haskell. So in all those applications, you have to process languages, as well as in writing a good old-fashioned compiler. So what we're going to do here is take an example, admittedly a small example of a language, and show how we process that. And the language we're going to look at is a language of numerical expressions. So these are expressions like 2 plus 3 times 4. You can see written here with parenthesized, so we understand what gets multiplied and what gets added there. Or expressions like 2 plus 3 times v, where v is a variable. So those are the sorts of things we're going to work with. What can we do with those sorts of things? Well, the first thing we might do is evaluate them. So if I say, tell me the value of 2 plus 3 times 4, what we have to do first is multiply the 3 and the 4, and that gives us the value 12, to which we add the value 2 to get 14. Now if we say, what's the value of 2 plus 3 times v, we can't give it a value, because we don't know what v is. But if I tell you that v is minus 2, then that works out to be 2 plus 3 times minus 2, which is 2 plus minus 6, so minus 4. So we can evaluate things with variables in them as long as we know the values that the variables have. So first thing we can do is evaluate these expressions. But that's not the only thing we can do. For example, if I give you the expression 0 plus 1 times v, I can simplify that. First of all, I've got 0 plus, and that just adds nothing, so it simplifies to 1 times v, and that simplifies just down to v. And similarly, if I had something like 1 plus 0 times v, that would simplify to the number 1. So we can simplify expressions even if we don't know the values of the variables that are in there. So that's another way of processing them. And finally, what we can do is, just like we would do for a programming language, we can compile them to run on a machine. So I'm sure you know that Erlang runs on the Beam virtual machine, just as Java runs on the JVM. What we can do here is build a very simple virtual machine for processing numerical expressions. Then we can write a compiler for those expressions into the programming language for that machine, and then we can run those programs. We'll see all that going on in our masterclass a bit later on. And you can see I've given an example of the sort of code that we'll produce. Just jumping ahead, it's going to be a stack machine where we put the values of intermediate calculations on a stack. So we've got the examples of evaluation, compilation, running a program, simplification. Those are the sorts of things that we can do with expressions. Those are the sorts of things we're going to see in the remainder of this masterclass.